Hey guys, welcome to the 7th episode of DP Education. Today we'll be doing number bounds in GCSE Maths. We'll be looking at upper and lower bounds as well as maximum and minimum values for calculations. And later on in the video, we will be looking at examples to help you figure out what type of questions could come up in exams. So let's get into it. First, we're going to be talking about upper and lower bounds. So, the main thing that you need to take from this is that when a measurement is rounded to a given unit, the actual measurement can be anything up to half a unit bigger or smaller. So here's an example that we could take. So, let's say the mass of a cake is given at 2.4 kilograms to the nearest 0.1 kilograms. Find the interval within which m, the actual mass of the cake, lies. So the lower bound would be equal to 2.4 minus 0.05, which is equal to 2.35 kilograms. And the upper bound would be 2.4 plus 0.05 is equal to 2.45 kilograms. So the interval is between 2.35 kilograms, which is less than or equal to m, and then a less than sign, and a 2.45 kilograms. This little area is called the error interval. So as you can see here, the actual value is greater than or equal to the lower bound, but always less than the upper bound. The actual mass of the cake could be exactly 2.35 kilograms, but if it was exactly 2.45 kilograms, it would round up to 2.5 kilograms instead. So, let's take another example. So, instead of saying that the cake was rounded to 2.4 kilograms, let's say it's truncated, so like cut down. So whenever a measurement is truncated to a given unit, the actual measurement can be anywhere to a whole unit bigger, but no smaller. So you truncate a number by chopping off decimal places. So if the mass of the cake was 2.5 kilograms truncated to one decimal place instead of rounded, the interval would actually be 2.4 kilograms, which is less than or equal to x, which is less than 2.5 kilograms. So if the mass was 2.499999, it would still be truncated to 2.4. Next, let's look at maximum and minimum values for calculations. So, when a calculation is done using rounded values, there will be discrepancy between the calculated value and the actual value. So here's an example for us to look at. So the question states that a pinboard is measured as being 0.89 meters wide and 1.23 meters long to the nearest centimeter. Calculate the minimum and maximum possible values for the area of the pinboard. So first, what we want to do is find the bounds for the width and the length. So as we learnt before, we minus 0.005 from a 0.89, which is 0.0885 meters, which is less than or equal to the width, and then a less than sign, and then 0.89 plus 0.005, so 0.895 meters. We could do the same thing with the length, as shown there. Then we want to figure out with the minimum possible area. So by doing this, we need to calculate what the two lower bounds multiplied together would be. So it would be 0.885 times 1.225, which is equal to 1.084125 meters squared. And we'll do the same thing with the two maximum bounds. So it would be 0.895 times 1.235, which is equal to 1.105325 meters squared. And well, that's the answer. Now let's look at question B. So it asks us to use our answers to part A to give the area of the pinboard to an appropriate degree of accuracy. As you can see, both of them having 6 decimal places is quite inappropriate. So the area of the pinboard lies in the intervals at 1.084125 and also 1.105325 meters squared. So the upper bound and the lower bound both round to 1.1 meters squared to one decimal place, So we could say that the area of the pinboard is 1.1 meters squared to 1 decimal place. So yeah, guys, thank you for listening. Make sure to like and subscribe. By the way, next video we will be doing standard form, so make sure to stay subscribed so then you know when our next video comes out. Thanks, guys.